We're really optimistic. All right, hi everybody. Thanks for joining us again today. We'll be starting the workshop with Kelvin and Ben from Optimism, an overview on code, an overview and code walkthrough. And without further ado, I will let Kevin and Ben take it over. If you have any question, you feel free to post it in the chat. We'll get back to them, if not during this workshop, after in the sponsorship channel in Discord. Thanks.
Yo, thank you. Hello, everyone. Welcome, welcome. Kelvin, can you help me with this screen share on the presentation?
Yeah.
I don't want to accidentally reveal your social media or something. Hey, everyone. What's going on? Welcome, welcome. Give us a sec as we throw up these slides. How are you all doing today? I'm very excited to see some unmuted faces. Incredibly exciting. I hope that we get lots of excellent questions that Kelvin will help me surface as we go. So it's great to see you all. It's good to be here. Sweet. All right. So we are preparing to hack, folks. Let's get ready. It's the Scaling Ethereum Hackathon. Get hype. Before we begin, I do want to let you guys know that if you're hoping to walk through the code alongside Kelvin, that Kelvin will be going over later, you can check out this link, which will redirect you to some prereqs so you can get downloading in the background. However, no pressure at all. If you don't want Docker to kill your neighbor's Netflix or something like that, of course, all of this will be recorded. All of the code and stuff is public. So you can go back, take your sweet time, pause Mr. Kelvin with some of these incredible shots that we're getting here with these incredible glasses. My
Damn,
God.
son, where'd you find this?
So in addition to that, I will say that I'm Ben, and next to me is Kelvin, who is currently manning the little soundboard we put together for this this workshop. So if you hear random noise in the background, that's what that is. Yeah, so I'm Ben, and this is Kelvin, and we work at Optimism. And we're gonna be talking to you all today about a couple of things. So the first thing we're gonna do, and I think the most important thing that we're gonna do, is to give you guys a little taste of optimistic Ethereum. Now, there's going to be some very familiar tastes there that you've hopefully already acquired, which is just the Ethereum developer stack. There's also some new tastes that will be unfamiliar, but hopefully very umami, or choose your favorite flavor. They'll be new, but hopefully they'll be fun. We think they're a lot of fun. So first, I'm just going to talk through conceptually some of those components. And then I'm going to step back and Kelvin's going to hop in. I will take over the soundboard and Kelvin will do some coding with you all. So we'll do it in words, then we'll do it in code. And then we're going to wrap up talking just very briefly about our plans for the hackathon and how we're going to support you lovely people. All right. Kelvin, are we checking questions on chat, by the way? I love questions. I love questions, folks. If you guys can get us to not finish this presentation because of questions, I'll be very pleased.
First question, when
L2, sir? Soon. Okay. I think we have a soundboard, so I guess we're buying into it. We have to accept some level of memery questions.
First question down. Let's go.
All right. So what are we building? So we are here building optimistic Ethereum. Now, what is optimistic Ethereum? In one exhale of a hit, or optimistic Ethereum is just like Ethereum, but with better scalability, 10 to 100x cheaper, and secured by L1. So basically, if you want to sum it up in a simple meme, we can make it look something like that. Okay, so there's the TLDR. I'm going to very quickly go over some of the underpinnings of how optimistic Ethereum works and how optimistic rollups work. I'm going to assume some context. If you guys want more, you can go check out other talks that we've done. If you guys have seen those other talks, you'll notice that I stole those exact same slides here again. Sorry, I'm not original. If it ain't broke, I'm not going to fix it. So thank you. But the basic premise of optimistic execution in general can be summed up in the following way. You don't go to court to cash a check. You go to court if the check bounces. So basically what we're saying is that we can get increased scalability in layer 2 because only in the event of a dispute do we need to execute the gas, the sort of full gas for the transaction, right? And actually run it on chain. And so this is where we get our scaling properties. Okay, so what does that mean in a little more detail? Okay, so I'm just going to walk you through very basically what's going on. So up on the top half of the screen here, we have L1, that's Ethereum. And on L2 is down below, and we have this roll-up state. And basically what we do is we go through a repeated process whereby a new transaction and a new proposed state is rolled up. Now, this is probably the most useful, although it does play very nicely. I hadn't thought of this into the whole taste eating analogy, but what does rolled up actually mean? Basically, it means that it's notarized on L1. It basically means we've put it into L1 in such a way that if we need to do a dispute, we can. But the other thing that happens is a proposal comes along with that transaction, and that proposal claims what the notarized transaction should do and would do. Now, the key property is that we have a period of time that is like a dispute period. It's called the withdrawal window sometimes as well, in which someone can basically challenge this behavior. But if no challenges, if the proposal basically goes unchallenged for this period of time, then we optimistically accept it, basically. We assume that it must be right because it's past the period of time at which it could be disputed. Okay, so again, this is a repeated process, right? We do it once, twice. Let's say now we have this new transaction getting added and someone proposes that they have all the money afterwards, right? That doesn't seem right. That seems like a problem. So what do you want to do? You want to do a fraud proof. So you go to L1 and you say, hey guys, this proposal for S2 here looks really good. But if you take S2 and you apply TX2 to it, I'm going to show you, you are not going to get S3. And so you basically prove that the proposal is wrong and you blow it out of the water and it gets eliminated.
Damn, son, where'd you find this?
Okay, so there's our soundboard for that. Okay, and then the other important thing I think to go over as I just try to breeze through this is that we basically have built something called the OVM, which allows that execute function during the fraud proof to basically be an EVM transaction. And so this is where you get all the wonderful EVM-like properties replicated into your layer 2. All right. So I tried to breeze through that a little quicker than I normally do, because what I want to focus on for this hackathon and for this presentation, for kicking things off, what do these things actually mean for someone as a developer? What does it mean if you're a hacker that's trying to go through and use our stack over the course of this month? So I think the first thing to say, right, I said before that there's some similar tastes, right? And effectively, that's quite true. I think the hello world example for a blockchain project at this point pretty much is to launch an ERC20. I mean, at least that's the case for Ethereum. And of course, that's the case on our chain as well. So Kelvin will go through very quick how to take an ERC20, turn it into an optimistic ERC20. And the TLDR is that it requires almost nothing, because you should be able to use all of your same tooling that you love to deploy and interact with Ethereum, but now do so interacting with optimistic Ethereum. So that all should be the same and super familiar. Now, there are new components that happen in this layer 2 paradigm, and namely, those arise from the fact that we now have 2 layers. So these layers need a way to talk to each other. And it turns out that that talking, sort of by necessity, is a little bit different. Okay, and generally, the way that 2 layers talk for 90% of use cases is a deposit or a withdrawal, right? You're either putting your money in from layer 1 so that you can use it more cheaply in layer 2, or you're pulling it out so that you can, take it or send it to an exchange or whatever. Cool. Okay, so we sometimes call, another piece of context that I want to share is that all of the deposit withdrawal tooling should be very easy for you. And for a lot of use cases, you can just use out of the box deposits and withdrawals. But it's still useful, I think, and very important for developers to understand what they are building when they're using some deposited funds on L2. What does it actually mean? Where did it come from? And how does the system work behind the scenes? So I'm going into a little more depth here than the abstraction for developers needs to be taken. But hey, we're at a workshop. We're going to kick things off. That's what we're going to do. Okay, so it's pretty simple. Again, up on the top, we have L1. On the bottom, we have L2. And basically, what happens is to deposit, what that really means is you're locking up funds on L1 because you want to move them to L2. And while they're in use on L2, they shouldn't also be usable on L1, right? That would be like a double spend, or it wouldn't really make sense. So all you do is you have a contract on L1 that locks funds, and it tells L2, hey, I locked up this number of funds, mint, and this was the person who did it, so mint them the equal amount of tokens onto L2. So these 2 pieces together are what we would call a deposit. Great. And of course, the exact inverse holds true in the opposite direction. To get your funds out of L2, you should no longer be able to use them on L2. So what you do is you burn those funds on L2. And once the dispute period passes and the optimistic state is accepted, this will unlock your funds on L1 and let you get them out. Yeah, excellent, excellent. Make sure we're checking for questions, Kelvin. Come on, y'all got to stop me.
Who triggers the mint of the L2 funds?
Who triggers the mint of the L2 funds? That is a very good question, and it's a great segue. So I'm glad we caught it. I just have this little slide here that's making these arrows bigger, but to emphasize that this is what I want to talk about. What mints the L2 funds, in some sense, you could even call it a cross-chain transaction, right? In reality, we call it a cross-chain message because it's more like the transaction sends the message, and then there's a transaction that is receiving the message on L2. But in effect, what allows this minting to occur are smart contracts talking to each other between chains. And so there are differences and similarities in the ways that contracts can talk to each other between chains. So I'm going to talk through those differences and those similarities. What we have strived to do in optimistic Ethereum is make that part of the protocol as similar to what we do in Ethereum as possible. So in Ethereum, the way that contracts talk to each other is a cross-contract call. And when you do a cross-contract call, you say who you're calling, and you give some data that you want to call them with. It's like your message, right? That encodes information such as I am calling this function, and I am providing these inputs to this function along with calling that function. And of course, how much gas you're going to spend. So we've tried to replicate that in intuition as much as possible for sending messages across chain. But you do have to do it with a different contract because it has to work with L2. So here's the interface. And exactly equivalently to what you can do on Ethereum now, when you get a message in a smart contract, you can check the message.sender. And you can see, who is this message sender? Do I want to trust them or not? Or maybe they've just given me some money, so I want to do something for them. So the other thing you can do, just like you can get the message.sender in normal Ethereum, you can get the cross-chain message sender from a contract.
Question 2 down.
Question 2 down. Hell yeah. Cool. Okay, so a couple of different things. I want to speed up here, Kelvin, make sure I got time for you.
Mm-hmm.
A couple of different things. The biggest difference in some sense is that there's no return data. So you can't do a cross-chain call to like a getter function, for example, and expect that data to be returned. And this is basically because they occur in different blocks on each chain. And so because it's not the same block, because they're two different layers, they can't sort of have that round trip communication. This is a very, very fun design space. Hint, hint, wink, wink. You might think of callbacks when you see this and see that you can only call functions one way. And indeed, we think there's a lot of cool stuff that can come out of this hackathon related to that. But that's the one difference. The other difference that's sort of related is that this communication is asynchronous. So there's a bit of a time delay. So we have a crazy time graphic here to describe that. And basically what that time delay is pretty short when you go in and you deposit funds, because a layer 1 message can sort of force things on layer 2 because layer 1 is the source of truth. But to withdraw your money or to send a layer 2 to layer 1 message, that takes a little bit more time because you have to wait for the dispute period. So those are that is basically what is the same and what is different at a very high level when you're developing on a system like Optimistic Ethereum. So I think if we have any other questions, Kelvin, let me know. And if we don't, we're going to switch off to Kelvin, who's going to actually walk you guys through coding this stuff up. Anything else?
I think that's it.
All right.
Let's go.
Let me switch seats and pass it over to Mr. Fichter.
Let's go. All right. Let's write some code. Well, I'm not actually going to write any code because it's bad practice to write code on stream. But why don't we switch? All right. So here's what we're going to do. I hope that everyone can see this. Yep, everyone can see this. Great. So I asked everyone to prepare for this. If you aren't prepared for this, don't worry about it. Don't do it now because it'll take you too long. So just watch the stream afterwards and follow along then. But essentially what we're going to do is we're going to run through the basic tutorial, and then we're going to sort of also run through what like an L1, L2 communication flow would look like and give you an example of how you can do that if you want to hack on that. So the basic tutorial is just sort of getting an ERC20 contract deployed and compiling and working, right? Pretty simple stuff. So if you download, if you go to Optimism tutorial, you will be able to clone this repo. And then all you really need to do is install it, right? Pretty simple. And then we're using Hardhat. So, Hardhat has this nice little compile. So I can run Hardhat compile and boom, my ERC20 contract just got compiled. This is the sort of standard flow. So the only sort of difference in optimistic Ethereum is we do yarn add this plugin. That's right. Add a plugin. And great. And then we just add this plugin to our Hardhat config. And we're also going to create a new network. I'm going to just copy the same mnemonic. And then we are going to specifically set this little flag that says OVM equals true. And for now, just to make our lives easier, because we don't have accounts with balance, we're just going to set a gas price of 0. Great. So pretty simple. And then compiling for the OVM is really simple. All we have to do, just like we did npx hardhat compile, right? We just add network optimism. Great. Cool. Oh, sorry. I forgot to put a URL in here. So this is we're gonna have a node running at 8545 standard port. This doesn't matter right now, but let's first compile. Great. So this is now compiling our contracts with the optimistic Ethereum Solidity compiler. Great. Perfect. So wonderful. So now you can see we have these two artifacts folders, artifacts and artifacts OVM. OVM means optimistic virtual machine, right? It's sort of just like the very slight tweak on the Ethereum virtual machine. Wonderful. Great. So similarly, let's, this is how we would test a Solidity contract. Boom, test it. Right? Come on, go. Great, wonderful, perfect. Now, what we're going to do is spin up our simulated development L1, L2 system. So this is if you download the Optimism monorepo and install it and follow the instructions that are in the tutorial here. We have this little Docker compose up thing that will spin up the entire system. And it spins up not only the L2 node, but it also spins up an L1 node, which is really nice for being able to sort of like simulate the behavior between these two systems. So this takes a minute to spin up. So we're gonna give that a second. I should have probably spun this up before. That's life. Anyway, let that run. Unfortunately, there's no clear indication when this thing is done. You'll just kind of know that it's done because it starts doing a lot. We need to change that. Sorry. Anyway, once this is done, we'll be able to do Hardhat test network optimism. And I'll give this a second to sort of finish up here.
Kelvin's machine is chugging along while simultaneously screen sharing, downloading like 17 YouTube videos, and spinning up an L1 blockchain and an L2 blockchain.
And an L2 blockchain, and the software that makes the two communicate with one another. So, but hey, it works. All right. So I think we're ready now. Sometimes it's a little bit slow because Ethers has an annoying little polling interval that takes 4 seconds. So sometimes it takes 4 seconds per test, which we need to fix. I don't know why Ethers does this, but let's see. Great. So we are starting our test now. Come on, go. There we go. So it starts, and then there you go. So you can see there's like this weird 4-second delay, which is
cool. Okay, can I ask a question, Kelvin?
Yes,
so what am I seeing right now? I'm actually seeing on the right-hand side a bunch of transactions that are this ERC20 test transactions.
Yep.
But they're being run on L2.
On L2.
On your local L2 environment.
So we showed how to do it, to deploy to L1, right? That's the flow that everyone is familiar with, deploying ERC20 to L1. This is just the basic flow of like, okay, we deploy ERC20 to L2 now. You can see, again, this annoying 4-second delay, whatever. Anyway, point is, you deploy to L2, it's basically the whole point of this section is just to show you the similarities between deploying to Optimism and deploying to L1. Perfect. Great. All right. So now we're going to keep this chain running in the background here. Whatever. Sorry for all the spam. You know what? Let's just let's move it kind of into its own little corner. So that's the basic flow, right? That's all we did. It's just a basic ERC20. We add this plugin. We add our Optimism network, and we're good to go. But then let's go into sort of what the more interesting, communication between the two systems looks like. So we've set up this example, this very minimal example of what it looks like when you want to deposit an ERC20 on layer 1. This is locking it up on layer 1, and then it sort of gets spit out on layer 2. And then we're going to do the whole process backwards. So we have these two files, very similar. This is the same exact ERC20 contract that we have in the tutorial. Boom, nothing different. And the only difference is we have this L2 deposited ERC20. So this is the sort of the contract that represents the tokens that have been sort of deposited from layer 1. And essentially, we've kind of abstracted a few things for developers to create a nice interface. But we have these two handlers, one for withdrawals and one for deposits. So you'll extend this or inherit this contract, which will give you these deposit and withdraw functions. And in this case, when a user calls withdraw, this function will be triggered. And in this case, you can see we're just burning the tokens on layer 2. Similarly, when tokens are deposited, we just mint on layer 2. And a lot of this complexity is kind of hidden for you in this sort of helper contract that we've built. If you want to see sort of the low-level information about how this works, you can take a look at this contract and get more information there. And then basically the flow will be that we have a standard ERC20, nothing special about it. We're going to have a gateway contract. And we're going to put funds into the gateway contract. And then those, when you lock up those funds in the gateway contract, they're sort of just going to appear on layer 2 after a little bit. And then we're going to burn those funds on layer 2, and we're going to sort of unlock them again in the gateway contract on layer 1. And this example.js file, you can ignore all this junk. But you can follow along, and it's pretty simple, right? We connect to both of our networks, right? We're going to have a wallet on each one of our chains. And then we have these two addresses that you don't really need to worry about. They're called the messengers. They're kind of the contracts that are responsible for doing this communication. And a watcher, which sort of just helps you, see when a specific transaction, cross-domain, cross-chain transaction has been finalized. So the flow is really simple, right? So step 1, we deploy our ERC20 to layer 1. Simple. This is the Ethereum, ERC20. Step 2, we're going to deploy our ERC20 to layer 2, right? So we're going to have 2 ERC20s now. And this is that special deposited ERC20 contract. Then step 3, we're going to create this gateway, an ERC20 gateway. This is a standardized contract that we provide for you. So you can also look at that contract and understand how that works under the hood. But the point is, it's sort of this contract on layer 1 that you hook up to both of the contracts. You say, this is the one on layer 1, this is the one on layer 2.
So one way to think about it, am I right, Kelvin, is like the gateway on L1 is like the thing that was locking and unlocking on the top of my diagram.
Yep.
And then on L2, the thing that was minting and burning is the ERC20.
Yep, that, right.
Got it.
And the reason we've chosen this design pattern is just because a lot of people already have existing ERC20s. You could, if you wanted to, build this gateway directly into the ERC20 implementation, but that's for another time. Anyway, so then once you've deployed the gateway onto layer 1, you need to sort of initialize layer 2 and make it aware of the gateway, the layer 2 ERC20. And so then we're gonna show you what the balances are, right? So on layer 1, we should have some balance. On layer 2, we don't have anything. Then we're going to approve the gateway to spend some of our tokens. We're going to call the deposit function and actually deposit those tokens into layer 2. We're going to wait for that deposit to be picked up on layer 2, and we're going to see that we have a balance on layer 2. And then we're going to do the process in reverse. We're going to withdraw the tokens back to layer 1. We're going to wait for that withdrawal to be relayed, and we're going to see that we have a balance, right? So pretty straightforward. now I'm just gonna, so we still have this node running here. So I'm just gonna run the example and hopefully this all completely works. Great, all right, so we can see it's deploying to layer 1, then it's deploying to layer 2.
Yes.
And then we are deploying the gateway. We're initializing the layer 2 ERC20. Boom, you can see that we have 1, 2, 3, 4 on layer 1 and 0 on layer 2. Now we're waiting. Oh, now we have 0 on layer 1 and 1, 2, 3, 4 on layer 2. Now we're waiting for it to come back. Yes.
Oh, it came back.
It worked. And it worked.
Oh, baby, it's triple.
Yeah. Yeah,
Oh,
it
baby.
works. It's functional. Oh, yeah. So this is really the, using these two examples, I think you can get a pretty clear idea of sort of what it takes to, deploy just a basic contract to layer 2, and then what it takes to sort of build an application that communicates between layer 1 and layer 2. And this is where the really interesting stuff comes in. So I don't know if we had a slide for it. Do we not?
We have a slide for it, yes.
For the info?
Of course, babe.
Where's the slide?
Of course we got a slide. Should just
All
be
right.
at the end of that presentation.
All right, we're going to switch you back to our slides so we can give you some information really quickly. All right, where are we? Okay, great. Okay, here we go. So if you would like to hack on Optimism during this hackathon, we will be very much active on Discord. If you go to optimism.io/Discord, I think you should get redirected, assuming we set that up correctly. Otherwise, if you go to community.optimism.io, you will find links to the Discord, and you will also find links to docs and stuff like that. So we're going to make a hackathon channel on Discord. And if you'd like to learn more, or if you'd like to start messing around, come hang, and we will be around.
Sweet. Thanks, y'all.
Thank you, guys. That was great.
Stuff.
That was really great. Thank you. Yeah, I mean, of course, like the best way to communicate is through Discord. At the moment, if you want to have feedback from, like, if you want to make sure someone catches it within the EAT Global community, it can be easier. But of course, like being directly connected to the Optimism team, which they're on Discord works.
We'll go hang out at the
We'll be in the
EAT Global Discord right after this. So y'all
Yeah,
can
you
come
better. No, for sure. Yeah, it would be great to see you there. Everyone, I know there was a lot of questions. I'm not sure everybody got answered. So feel free to come and post them in the EAT Global Discord channel. And Kevin and Ben will be there for you.
Cool,
So
cool,
thanks,
cool.
everyone.